what a guy could do with some duct tape. Oh, yes. Oh, yeah. I'm so sorry. Want to ask any questions on 8.1 or 8.2? Pretty simple, right? If you don't have any, I can continue on. If you do, I can. Here's what the day's going to be like. I have 6 people outside the class. We do have a long period of time in here, like we have an hour and a half in here still. So this lesson only takes 25 minutes. Just be aware. So some things that you could do today is work on the homework after I give it to you, right? Like you already have it, it's 8.3, 8.4. But I would like to wait. Remember how last time I talked about needing to do the rest of 10.7, but we didn't have last time because we were a shorter period, right? So when the sophomores get back, and Paige, I'd like to go over 10.7, which is taking polar equations and put them into rectangular equations and putting rectangular equations into polar equations. Make sense? You will not turn in 10.7 until Tuesday. I will not be here on Tuesday because I will be at a meeting, okay, just to be aware. So therefore, you will have a review day on Tuesday, but if you'll notice in your packet, the review is already within it. On Thursday, you will be taking the test. Any questions on what I have for you there? The test is just going to be the stats part. Okay? Then remember, after the stats part, we come back and start doing polar stuff again for 2 more lessons. So really, you guys have to deal with this screen for 3 times today and 2 more times. And then really all the other times are reviews and tests. Okay? Did everybody remember that I did talk about the 21st being the dead day, right? Did we talk about that? Okay. Any questions? You guys ready to rock? All right, here we go. Yes. It's the S of X one. It's in the same spot with all the other information, so it's the S of X. Answer your question? And then the other one's sigma. If you use sigma, that's okay this time, but on the test, I want you to use the S of X. Yes, sir. Okay, I can show you that. Just got to find standard deviation squared. Once again, I don't even know what variance means. Really, I don't. So I wonder if I closed. All right. So let's try and do standard deviation first. So standard deviation, not standard deviation, but percentiles. Okay, so let's say I write some numbers here. 1, 2, 2, 2, 3, 4, 5, 5. How many is that so far? And then 6, 7. Okay? I have 10 numbers up there. I want to find the 20th percentile. Okay, so I'd go 20, or 0.20, times the number of terms there are, which is 10. So that is 2. Now, does that 2 mean it's 2? No, it means the second number in order. So that's the first number, that's the second number. It did so happen to be 2, but it doesn't necessarily mean it has to be 2. So like if I was looking for the 80th percentile, 0.8 times 10 would be the 8th digit. So 1, 2, 3, 4, 5, 6, 7, 8 would be 5. Answer your question? Now remember, if it's like 8.6, that's a number in between 5 and 6, right? I'd go to the higher number. Answer your question? 73. So you'd go 0.8 times 73, whatever that number is. Count it up. It needs to be in numerical order, right? Did you have a question, Olivia? Then that's awesome. It's just 5, right? And notice, remember on my example with my test being 100%, how many people got that score? We think about 8 because I was in the 92nd percentile. And that makes sense that actually numbers can be in multiple percentages. Because really, the last digits, if I'm doing it my elementary way, if they ask for the 98%, that'd be a 100 score. 98 percentile. But notice 92 all the way to 100 have the same score. But notice they always go to the lowest amount if they have the high score. So for example, if I had 2, 2, like 1, 2, 2, 3, right? These numbers are all the same. So technically they'll go to the lowest number. So this is actually the 40th percentile, where notice this could be the 80th percentile. But they'd always go to the lowest number because you only beat 40%. Does that make sense? With me on that? Everybody good? Chuck. Up. Why do we round up? Because you want to beat. And so therefore, if you pick the lower one, are you really beating him if you're at the 85th percentile? So that score above will always beat everybody below it, right? Whereas the bottom one might have not. Does that make sense? Okay, 8.3, we're actually using notes off of a screen today, just because it's easier to do so. So we're going to talk about different types of sampling. How do we get our data? Last time in class, I went ahead and just sampled everybody, didn't I, to get your shoe size, correct? That is called a convenience sample. Notice you were in my classroom, you were easy to get some data from, I used you. Convenience. Okay? Other things, maybe you're standing outside of school asking kids as they walk out. You're only picking kids that are walking by you. It's convenience. People at Disneyland. You guys ever go through Disneyland and those people are already, can I ask you a few questions? That's a convenient sample, right? Does that make sense to everybody? Okay, a self-selected sample. Let me give you an example of that. How many of you guys have ever been to a restaurant before and it has a card and it says, hey, if you have any comments, leave a comment on here or take a little survey? You guys ever see that stuff? Or I kind of think of Yelp or not Rotten Tomatoes, but like those food ones that they tell you how well the restaurant is. That's a self-selected, right? Nobody called you up to do a Yelp review. You personally decide, hey, I'm going to throw my information out here. And I always take Yelp for a little bit of a grain of salt because it's either, oh, it was perfect, or this place is hell. You know what I mean? There's really nowhere in between. It's either, you know what I mean? It's the people that really want to tell you about it or the people that thought it was totally garbage, right? It's hard to see things in between. But that's a self-selected sample. Those people chose to do that on their own, right? They had an opportunity, but they chose to do it. Nobody asked them to do it. They just chose to do it on their own, right? Does that make sense what I'm trying to talk about? Like they had an opportunity to take the survey that's sitting right on their table, but how many of everybody does it? Not everybody does it, right? It's people that choose or self-select to do that. Does that make sense what I'm trying to talk about there? Okay. Systematic sample. Let's say I alphabetize you guys and I pick every third person to ask questions to. It's in a specific pattern. I go through the phone book, if you guys know what that means, and pick every 20th person. See how that's systematic? It has a very specific way you're picking people. Now, on our test that I want everybody to get 100 on, this is kind of the things that make people miss points because they don't study these. So these 4 things and the next 4 things I'm going to show you, you need to make sure you really understand what they are. Okay? Has anybody heard of the word bias? What is the definition of bias? Go ahead. You have your hand up. You're the tallest hand. Nope, there's like 5 people. Could be a prejudice in a way, kind of a thing, whether it be a good prejudice or bad prejudice, right? Could you guys agree with that definition? Yep. I used to grade that way. I used to have grade on a bias. I'm not kidding. When I first started, kids that I really liked, I wouldn't grade them as hard. Kids I couldn't stand, I'd grade them harder. Same work, I'm like, that's only -1. And other kids, I'm like, -4, damn it, and it's the same work. And then I started saying to myself, I'm like, that's really not kosher, you know? So I don't grade your guys' test that way. I usually grade just your first page, and then I flip the page and I grade everybody's second page, everybody's third page, so I don't know who I'm grading anymore. So it keeps me a little bit not biased. But I did. I found myself knowing that I was doing that. So therefore I corrected myself. You know what I mean? I found a way to do that. Any questions on kind of what bias means? Are you pulling out some glasses? Have you had glasses for a while? Have I seen you wear glasses? Okay, here we go. A survey, somebody wants to survey eating habits of the community. A television crew decides to go to a food court in the mall to talk about eating habits. What kind of sampling is that, first off? Convenience. They're going somewhere, they're getting responses, right? Is it biased? Why, Chuck? Because you're at the food court and you're like probably pounding back one of those cheesy cheesesteaks. Or what else is there always? A good old hot dog on a stick. I love a good hot dog on a stick. Right? You guys get what I'm saying though, right? Might not be the best food choices for everybody. Maybe that's not the whole sampling where somebody might bring avocados and carrots. I don't know. I don't know if that's even a deal, but you get what I'm going. Get what I'm saying. So yeah, probably not the best bias. Okay? Ooh. Ooh. There we go. How about, oh, nope, that's not the one I want. A supermarket manager wants to find the percent of shoppers who use coupons, so he stands in the gift card aisle and asks people. Is that random? I'd still say it's convenience. Random is more, I don't know if did we go over random? Did I go through all those? Random. Random is actually, the only way to say random is kind of like pulling stuff out of a hat. Like everybody's name has an equal opportunity to be pulled. Self-selected is, it could be random as the same way. Like, could you get the same results out of random and self-selected? I believe so, in my opinion. Because random, though, is that every person is equal opportunity, whereas on a self-selected, not everybody is equal opportunity, because you already have in your head what you're doing. That would still be convenient, because you're around people and they're conveniently coming or asking questions. Does that make sense? Best way to think about a random thing is putting, like, let's say I make you guys go up to the board. How can I do it random? But did any of your teachers do the toothpicks or like the popsicle sticks and they just grab one? That's completely random. I did that one time for 7th graders. It worked for them. I would not suggest it for a high school thing. That was weird. Onward. The next thing we're going to talk about is observational studies. Okay? How are we getting our data? Well, a lot of times we think of surveys, like what we've been talking about up above, where a lot of them were surveys, where we're having people answer questions for us, right? But we could also have like an observational study, where people don't know that you're being observed. Kind of creeperish, but think about the cop shows. You know how they have the one-sided glass where they can see you, but you can't see them? Has anybody ever seen those things where they put kids in a room and see what toys they want to play with? You know what I mean? That's an observational study. The kids in there don't know they're being studied. They're just being them, right? But the person behind the glass is saying, hey, look what I'm seeing. I'm picking up items that can help us. How are you, Sally? I think that was Sally. I'm doing well. I'd say hi. No, guys, the more the better. I probably disturb exactly what he said more than they do. Maybe. Some people get frustrated. Kelsey. Just teasing. All right. Controlled experiment. That's kind of like I had it when I was in high school. How many of you guys had your wisdom teeth out already? And you guys have pain? Swelling? I had neither. Experimental drugs. Plus I got paid $500 for it. It was awesome. And I sat on a chair for and watched movies and ate pudding for 8 hours. It was awesome. And I got a pager for a week. That was legit. That made me all my friends were so excited that I got a pager. You guys are like, what the hell's a pager? A pager is, cell phones were there, but they were just so expensive to use. So therefore, you had my mom always made sure I had this little pocket in my shoe that always held a quarter. Because that's how much a phone call cost, was a quarter. Anyway, so a pager was an item that they would call, your pager had a phone number, and you would call it, and instead of talking to it, you'd put your phone number in to say, hey, call me back. You could even do number messages, if somebody did 911 with their number, that means this is an emergency, call me. Does that make sense? Anyway, I had a pager for a week so that they could call me back. It's like, how is your pain right now? I'm like, 0. I was eating pizza that night. Did you eat pizza that night? But that night, touche, buckwheat, take that. Okay? And like I said, a survey is just a basic thing that you're going up asking people questions, right? So once again, observational. They don't really know what's happening. You're just watching and kind of taking notes on what's happening. A controlled survey, once again, I didn't know if I had the real medicine or if I had the placebo. They knew, right? Does that make sense? Have you guys ever heard that some people even have placebo, have no pain and stuff because they think they're getting the medicine? Right? That type of stuff. Does that make sense what I'm saying? So anyway, those are all important. Ladies and gentlemen, that's 8-3. Pretty simple, right? 8-4. You guys ready for that? We're almost halfway done. We are halfway done. 8-4. I should have did 8-2 and 8-4 together just because they go together so well. 8-2 talked about the standard deviation. Remember, and how I talked about the normal curve, how you guys never want to be graded on the normal curve. Just basically random questions being asked to people, like certain amount of, you're asking them questions personally instead of observing what's happening. My normal curve on here kind of sucks, but I think it'll do, okay? How many of you guys remember what just like the normal curve was? Remember we talked about, how many did you guys take? 2 standard deviations or 3 standard deviations? You guys were 3 to cover your data. And like I told you, remember how I told you I've only seen 4 standard deviations once in my life? This will explain why in just one second. If you're under a normal curve, this is the X-bar, which is the average, right? Then we all know if we go out the same distance in both directions as the standard deviation, that's considered 1 standard deviation. You guys agree with me on that? Well, 1 standard deviation, so 1, I'm going to put the sigma because that does represent standard deviation. 1 standard deviation represents 68% of our data. 68% of your data should fall between 1 standard deviation away from the mean. So we'll give an example in just a minute how that could work in just a second, okay? Because I just saw your look. You're like, what the hell does that mean, right? But it'll make sense in just 1 second. 2 standard deviations covers 95% of your data. So could it make sense that some of my classes got their information covered in 2 standard deviations? 95% of your data could occur. Yeah, that can mean that all your data could be covered in 2, wouldn't it? Now here's why 3 is a common one though. 3 standard deviations is 99.7% of your data. So how much is left over? 0.3. It's all right, Uncle Burger. 0.3, right? It's like hitting the lottery to get something in the fourth standard deviation. It's not very likely. Does that make sense to everybody? Does it make more sense why you hit 3 standard deviations a lot? Because 99.7% of your data usually covers in there. So therefore, most of the time, you will hit 3 standard deviations. Yes? This is on the normal curve. This is stuff you just need to know. After 1 standard, it's not a formula. It's kind of a formula, but it's a representation of the normal distribution. That's what they hear, or the normal curve. So when you look at that, after 1 standard deviation, if it's a normally distributed, you'd have 68% of your data between 1 standard deviation. This is a number you need to know. It will be on your test. Okay? After 2 standard deviations, it will cover 95%. 3 standard deviations would cover 99.4, and then notice usually at 100, at 4, you'd cover everything for sure. Make sense? I don't think so. I don't really like what my step level, right? But just knowing what it is, I don't think it will. I don't know about that, to be honest. That's a good question. Okay, let me show you how this could kind of work so you guys could understand what it's meaning. Here's once again our normal distribution. That's pretty, isn't it? Okay, here's our X bar, or our average. Let's say we're talking about test scores. A good test score average, when I see it, I feel good about 80%. Right? When I see an 80%, I feel good. Let's say I calculated our standard deviation to be 5. Now, once again, what does 5 mean? The average distance away from the average, right? So each score is roughly 5 points away from the average. So what would be the values of 1 standard deviation? What do you guys think? Yes, no? You had to do this last time on your homework. 75 and 85. Those values are 1 standard deviation away from the mean, aren't they? So ladies and gentlemen, how much does this area cover? 68%. Now, what does that mean? So to explain what that's meaning is, in our case, 68% of the test scores in a class are between a 75 and an 85. Does that make sense? How about what's our 2 standard deviations? 70 and 90. So we could say what? 95% of our information's between a 70 and a 90. And that's actually pretty legit. Sometimes you have people that are a little bit lower than a passing grade. Not as many, but you have some. And you have some that did really well on their test as well, didn't they? Okay, does that make sense what I'm saying? Could you see it work like that? Okay, and then obviously 95 would be representing the third, and a 65. Now, I got a question for you. Okay, so how much is this first standard deviation? 68%. So how much is just this region right here? That region. What is it, you think? 34. Is that what you said and you just weren't sure? Okay, because notice those two together are 68, but it's a proportional. That's what a normal curve is that it's proportional about its average. Okay, so if he's 34, this is 34. So what would I say? What if I said, how do I say this? What percentage of students scored a 75 to an 80? You'd say 34%. Does that make sense? How much was 2 standard deviations? 95. So we know from here to here, this is 95%. How much was between here and here? 68. So that's already within that section, is it not? So how much are these little wings? Well, what's the difference between 95 and 68? 27, right? What's half of 27? 13.5. So this region right here is 13.5. This region right here is 13.5. So far, so good. Are you guys understanding what I'm saying by that? And then what's the third standard deviation? How much did that get us to? 99.7. So what's the difference between a 95 and a 99.7? 4.7, right? And we'd cut those in, how much? 2.35. Does everybody understand why that section's 2.35? That section's 2.35. That's meaning percent, right? So what are these little wings? How much are they? How much is left over? 0.3. So I go 0.3 divided by 2. So these are 0.15 and 0.15. Does everybody understand how I did that using the standard deviation values? That I could do each individual chunk on how much this standard deviation is technically worth away. So now I have this question for you. What percent scored a 65% or lower? 0.15, right? Percent. Okay. What percent scored a 90% or lower? 90% or lower. Well, I'm going to scroll up. So 90% or lower is that guy, that guy, that guy, that guy, that guy, that guy, right? What would we know? Can I ask you guys this question? What do we know about this whole side? How much is this worth? Could you guys agree 50%? Because it's half of our normal curve, right? So we already know that's 50%, plus I'm going to add him. So now I'm at 84, right? Then I'm going to add him 97.5%. See you, Sally. 97.5% scored a 90% or lower. Okay. Could I say what percentage scored between a 75 and a 90? How would I do that? I'd go 34 plus 34, which is 68 plus that. So 81.5% of the people scored between a 75 and a 90. That's pretty good data, isn't it? If you really think about it. You know what I mean? If this was an accurate test. If we really do this on your guys' test, we could show you how that worked. Like on your next test if we wanted, or if I put this data into it. You could see the standard deviation and really kind of how that works. No. Yes. Because once again, what is this all going off of? The average and standard deviation. You can't find either of those without taking data, right? Because once again, is every standard deviation, like, is your guys' standard deviation going to be the same as second period standard deviation? No, because their distance away from their average might be closer than your guys' distance away from the average, right? Does that make sense? So therefore, your standard deviations could be different. Well, if it's fully, if you have more than a couple, they're no longer outliers. Those are fun numbers you just come up with, by the way. So that's really just random stuff in general, right? So it might not be in a normal curve. Because this is based on a normal distribution. Okay? Could you have something like this next test? I hope you guys are skewed. Let's say Because once again, you might have some people that are a little lower that might skew your data. Oh, that's a perfect normal curve, sorry. Oh, shiz. Let me just graph it and then we'll put the average. Let's say your data is more over here, because I hope that you guys get a lot of 100%, right, on this test. But your average, because somebody might have screwed up, lowered your average down, right, because of those outlier type situations. So is this normally distributed? No, we call this skewed right. That's actually could be on your test, by the way. Okay, and then you have stuff that maybe like one of our tests, remember some of those tests that we really messed up on and some of you guys really scored pretty low. There were some kids that did really well, but I had a majority of my information over here, and then I had some really high scores, so your average could be like right there. Oh, hard times right there, brother. Skewed left. Okay. Sir. I was going to say, brother, L. Yes, it's off to the left. It's not centered. It's not centered about the average. That's why most of your information is to the left of the average. It's being skewed to the left instead of being centralized about it. Okay. Any other questions? That's it. Until the kids come back, those 5 kids. So I'm going to... interesting.
I have to take the whole ASCII place to get to Spanish 3. Like, this doesn't even have any questions about Spanish. What am I doing?
But it's your preparatory entrance to college exam. They're just making sure you could be college ready. It's to make sure you're ready. Okay, guys, here we go. So we're going to finish up 10-7. 10-7. Okay, and the only thing we did not cover on 10-7, let's do a little review for you. Remember, if you are trying to go from a rectangular point to a polar point, here's the equations that you're going to use. Remember, a rectangular point is x, y, and you're going into a polar point, which is r theta, correct? So we want r in terms of x and y, which was the equation of the circle. X squared plus y squared is r squared, correct? You guys remember that? It is Pythagorean theorem. Then, theta, we know that tangent of theta is always being represented by the y over the x, right? Agreed by that? Okay. Now, if we're going from polar to rectangular, notice, once again, that's r theta. Using those to go into x, y. If you recall, x is r cosine of theta. Y is r sine of theta. Any questions on how I have those? Those are your 4 equations that you really need to memorize for polar stuff. Okay, to switch back and forth. Because these are also going to help us switch our polar equations into rectangular and our rectangular equations into polar. Because if I know the tangent of theta, I don't know what the angle is, but if I know that tangent is y over x, could I not take the arctangent to find that angle? Now understand, you really want to represent where that angle is at. So remember, if I do the arctangent of theta, and I'm in quadrant 2, where is it going to give me the answer to? Down here in quadrant 4. But then I use that as a reference angle to find our angle, right? If I'm down here in quadrant 3, they're going to give me my tangent answer up here in quadrant 1. Because those are both places where tangent's positive, right? So I do have to use a little bit of thinking there, but in general, that'll help us. Oh, Alicia, what did you add? Let's see. This is my buddy. Let's see what she's selling on the old Yarcell site. Huh. Is that really what you're selling, Alicia? Whoa, not going there. That's not, I went away. That's swimsuit. Awesome. Luckily, it's just swimsuits. Woo! Scary. Especially because of the school computer. Jobs. It's all right. It's a swimsuit. Thinking outside the box. Note to self. Love you all. Okay, here we go. We're going to start. What did I do wrong now? I won't just post this one. Just easy. Okay. Y. What's another name for Y? Nope. Close. R sign. Remember, we're not on the unit circle, so we're talking about any Y value, right? So that's why it is R sign about. If I was just in my unit circle, would it just be sign? Sure. But I can be in any Y value, right? What is X? R cosine, but I'm going to square that. So that's R squared cosine squared. Do you guys agree? Yes, everybody good? Now, usually when we're in polar, we want to solve for R. So I'm going to get this R and I'm going to divide him. And I'm going to get this cosine squared to the other side, so I'm going to divide him. Not close. So this is R on this side, and you're close. There is a tangent because remember, this is cosine, cosine, right? So what is this? Tangent. And what's the other one? So notice, guys, you still got to kind of know some of your identities, don't you? Notice, are we in terms of R's and thetas? So therefore, we're done. We are in polar. Any questions there? Okay. Let's take some polar equations and go into rectangular. We all know what this picture looks like. What is this? There you go. So it's 1, 2, 1, 2, 1, 2, 1, 2. Does anybody kind of know what the rectangular equation is going to be? Ladies and gentlemen, what's another name for R? Isn't that the square root of x squared plus y squared? Now, I had some kids say, well, that's just x plus y. Why is it not? Because of that plus, right? Now, if it was timesing, it would be able to. But because it's addition, once again, order of operations says I have to add those before I take the square root. So I can't truly do that, can I? So what could I do to get them just x squared, y squares? Square both sides. With me? Next one. Okay. What's another name for secant? 1 over cosine. Whenever I see a cosine, what do I want with him in polar? An r, right? So can I times him over and get an r cosine? So therefore x equals 1. So it's just a straight line. It's like this. Is one of the evil lines. A vertical line. It's not illegal, it's just not a function. All right, so now I have just theta this time. Do I have an r with him? So what does that mean? It says no matter what our r is, our theta is always going to be what? Pi thirds, right? And isn't our radius always going to be on the line of pi thirds? Because if I know my angle is pi thirds, I just put the radius on where it's at. So once again, if I don't know what my radius is going to be, isn't that just a line? Because if my radius is 1, I'm here. My radius is 2, 3, 4, and you get what I'm saying. Or it could even be 0.5. But what if my radiuses are negative? Then that means it pushes it through, so I got to continue it down here, don't I? Does that make sense why it has to be in quadrant 4 as well? Because if your radius is negative, it would push us through. So that's why I also need the point on 4 pi thirds. That's why I need that line on 4 pi thirds, because it would push us through over there, wouldn't it? Does that make sense to everyone? Okay. So notice, though, what is the equation of this line? Remember, when it's the equation of a line, we have y equals mx plus b. Do we already see our y-intercept? What is it going through? 0, 0, and all of our angles go through 0, 0, correct? So what are we missing? Our slope, huh? Do we know a point on this line besides 0, 0? Don't we know this point's -1/2, comma, root 3 over 2 somewhere? Right? Is everybody with me on that? So, isn't that -1/2 here? This is root 3 over 2. I don't know about you guys, but that looks like rise and run, which is slope, right? How much did we rise? Well, if I'm going from here to here, I went down root 3 over 2. How much did I run? Well, if I went from -1/2 to 0, I ran 1/2. So times by its reciprocal, which is negative root 3. Our slope would be then, the equation of this line is y equals negative root 3x. Well, I actually did, because remember, right, do you want me to do a little bit better for you? Here, I'll make it a little prettier. So we know that point is over 1/2, so this way, right? And then up root 3 over 2. Now notice when we're talking about equation of a line or slope, we usually go from this point. How much should we go down? Right, Kelsey, we went down negative root 3 over 2. Now the location of this is at -1/2. How much did we run? 1/2, right? Does that make sense? Or you could do rise root 3 over 2 and run -1/2. Either way it works. Do you remember doing that back in the old 7th grade days? Okay, and then when we did that, once again, we got y equals our slope, which is negative root 3x. Okay, the key thing here, though, guys, is understand it just doesn't stop in quadrant 2 because it has to push through, right? And the reason why it's pushing through is because your radius could be negative. Did you guys get the problem set, the extra set? It can't, but so therefore, if it was our radius is negative, because remember, like I was saying there, Mr. Bradshaw, if I would always be on this line right here, right? But if my radius is negative, it can't be. But could it be in a polar point as negative at the beginning? Do we see it as a negative radius? We have. -2, comma, pi thirds. So I draw pi thirds. Then I have to push through. So hence why I'm down here. So if I had negative radiuses as a point on angle 2 pi thirds, I would push myself through. Nope, that's a different equation. That was a different equation. I can talk to you if you need to. Did I show you guys the homework last time? If not, let's see, what do we got here? Where did I tell you? Where's it at? Nope. Somewhere here. Uh-oh. You do? Can somebody tell me just to make sure? 10-7 was 33. 37. Okay, so really quick, ladies and gentlemen, let me just explain what's happening next week because I won't see you any of the days. Okay? So, Paige, when are you leaving? Are you going to... My wife talked about going to Disney. If I'm down there, I'd be all like, Pageroo, where are you? I might be... No, that's not why I'm gone, but the wife wants to go down just for Saturday. It's called Planes, and they're free. Yes, I do. She works for the airline, yes. It's really nice. Anyway, if I know you're there on Saturday, Paige. Oh, screw that then, Paige. Retake, you could do it in the morning on Tuesday, or you can come Wednesday. I'm here Wednesday. I'm just not, I had 2 meetings that ended up both on A days. So I'm actually even here first period and second period on Tuesday. I'm just not here third and fourth because I have to leave the second half. And then on Thursday, it's supposed to take up all of the day. I do get here at 6 a.m. on Tuesday because it is driver's ed day. So you can come right in then. I can hook you up. Any questions? So that's what I was going to bring up. If you guys have any questions on this 10-7, just come visit me in the morning. I won't be in here to class to help you, but I could be here in the morning if you needed help, okay? You could even do it now if you wanted, because we still have a half hour, right? Does that make sense what I'm saying, though? Like, if you guys need help, I will be here that day. Just come and do it. Now, remember, if you would like to increase your grade just by doing just test corrections, that is by Tuesday. Okay, so if you guys want to even work on some class time and get it done on Tuesday, that's fine because you have the review with you. You guys could probably do the review right now as well, right? You know what I mean? It's that easy. Anybody have a question on what we're doing and where my expectations are? We're done.